Okay, everybody. So we're going to go ahead and apply this part three of elimination. A lot of you, again, we're very comfortable with the process. It's just the word problems that tend to throw us off. So let's go ahead and take a look at one. Mrs. Langelli bought her students some wonderful math supplies. She bought this fancy double pack of pencils, and then she bought this really awesome calculator. Um, Now, she ended up buying 4 packs of pencils and 11 calculators, and that's how much money? $275.89. And here's one more clue. The calculators were $16.34 more than the pack of pencils. So how much does each item cost? Whenever you read a word problem, whatever the question is going to tell you what your variables are going to stand for. Okay? So I see that my variables, I'll call them P and C, pencils and calculators, but not just P and C. And I'm not just going to, what I see a lot is I just see kids write like pencils and then I see like calculators. We really don't want just that because well, let's look at what they're actually, is it the number of pencils? Well, let's go look. No, it's not the numbers, it's how much each one costs. So I'm going to write the cost of the pencils and the cost of the calculators. Now look at your hints. Clue number one, she bought 4 packs of pencils and 11 calculators and it cost her that much money. So that would be 4 packs of pencils and 11 calculators and it cost her $275.89. The last clue is that the calculators, so what letter is that? That's C, were 1634. So the word were is kind of like the word is. 1634 more than. I know sometimes kids not sure what to do with that. That means you add, so I'll circle that. That means you add 1634 to the back. And what is it 1634 more than? The pack of pencils. So my second equation follows that it's calculators equals pencils, and they are 1634 higher. Now I'm going to take that system of equations. System of equations means that we have more than one. Okay, put them over here. And I have to get it set up for elimination. So this top one is ready for elimination because it has the P and the C and then the equals and then the number. Let's check if the next one matches as well. It doesn't. It needs to have a P and a C and an equals and a number. So that tells me that the P is on the wrong side. So I have to move this P over by making it a negative P. Let's rewrite this equation now. That's negative P positive C equals 1634. So we rearranged this equation so that it looked like the yellow equation or this gold equation up top. And again, you can see a P, then a C, then the equals, then the number. I'm going to rewrite them because it's just easier to see them if they're rewritten. And I think I could probably just do a quick duplicate that way to save some time. So there's the first one, and there's the second one. If I move too fast, please just slow down the video, okay? Let's see, I'm going to move this stuff over just a little bit so it's all in line. Yeah, that looks really nice now. Okay, now in ninth grade, most of you took Algebra 1 in ninth grade. This is called elimination. For the majority of kids, when I taught them, here's what we did. We remembered there's a 1 in front of this P. Because there's a 1 in front of this P, I always told kids to put that up there. And if there's a 4 right there, you put it down here. Then check your signs. Positive, 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 negative. As long as you have 3 positives and 1 negative, or vice versa, you're good to go. Maybe put a star by that if you're not sure what I mean so I can explain it in person. So then we're going to multiply a positive 1 through, which is really nice because multiplying by a positive 1 does absolutely nothing except kind of reinforce that, it could have stayed the same. Now multiplying by a positive 4 does something, so we need to be a little more careful with this. That's going to be positive 4 times negative 1 is negative 4p. Positive 4 times positive c is positive 4c. Some kids just make that 4c. And then I really want to get my calculator. And because I already did this problem wrong once tonight, well, I like looked at the wrong prices on Walmart, which was not super helpful. I'm going to do 4 times 1634 on my calculator because I don't want to mess anything up. And that's 6536. 6536. And now I am going to continue to use my calculator here. And what we do is we add vertically. That was in the directions. You learned this in Algebra 1. Okay, we're just doing it with word problems now because we probably didn't do enough of that in Algebra 1. So the p's cancel themselves out because one's a positive and one's a negative. That should always happen. 11 plus 4 makes 15 c's. And 275.89 and 65.36 is a total of 341.25. And here's the magic. It really doesn't look nice, but it's now time to divide by 15. So if we divide by 15, we end up with C equals, because we're trying to solve for a single variable. We're following these steps up here. We end up with 22.75. And I promise you, I was at the Walmart website today, or at Walmart's website today, and that's exactly how much is a cost of a calculator. All right, so I'm going to go ahead and circle that because I have one answer. Now, if we look at the steps, if I can get rid of this calculator, I'm so bad at getting rid of the calculator. Here we go. You can see that we multiplied, we added vertically, and now step 3, we're going to substitute that into one of the original equations. It really doesn't matter where you solve it in for, so just because it was the least messy, I'm going to pick this one that I just put 2 blue stars by. 4p plus 11c equals 275.89. So that's 4p, 11c. Now we're putting it in for c because it's a calculator, not a pencil, a pencil pack. And I was noticing, now this is the year 2023, so this could be different if the video is in a different year, but I was noticing some solving mistakes as you went along. So please watch very carefully, because there was just a little bit of concern when I was noticing students solving Algebra 1 problems. So the 4p carries down. You put that in your calculator, which I promptly seem to have forgotten to remember. There we go. All right, that's a big 250.25. And then that carries down. It is a long process, but as long as you're like careful, like it's okay. So minus 250.25, this is called eliminate. Well, this is just called solving, but the whole process, what we were starting from start to finish, what is that called? Elimination. It's really important that you learn your vocabulary if you're not sure what this is called from Algebra 1. So 275.89 minus 250.25, and what do I have? I have 25.64. So now I'm here, and that must be the price of 4 packs of pencils. So I'm going to divide by 4, my math tells me, and that is correct. I did pull this from Walmart today. So it's 641, but I tell you what, before we circle it, let's go ahead and notice that P stood for the cost of the pencil packs. So let's say 641 per pencil pack. All right. I truly believe in the power of word problems and like kind of marrying together like the art of math. That sounded so awesome. Okay, example 5. Find the solution to the following system using equation or elimination. And this one I thought was good because it's just math, but it's kind of harder. So check x and y equals and a number, x, y equals a number. That tells us that it's ready and it's in the right form. If you're feeling like rambling is happening, you need to stop the video. You need to go get a drink of water before you start this with me. So this is already in the form we want. So I'm going to take the 3 and put it there. I'm going to take the 2 and put it here. Yes, some of you are wondering why I'm not using a negative 2, and here's why. positive, 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 negative. As long as you have 3 of one and 1 of the other, you're golden. And that's for the 4 numbers in the front. It does not have to do with the 4 numbers in the back. So we're going to distribute 1, 2, 3. And that's going to be negative 6x, positive 12y, and 30, positive 6x, positive 4y, and excuse me, that's negative 20. Let's see, we did it right because I see these cancel out. They make 0, so we don't need them. These make 16y, and this makes 10. When I divide by 16, it's not going to be a clean answer. I do know that reduces to 508. If you don't know that, let's make sure everyone is comfortable with their calculators. I'm a little concerned that if, oops, sorry about that. I'm a little concerned that if you don't know how to use your calculator, that you're not going to learn or that you're going to guess. So just use it and it will help you, okay? And this isn't a word problem, so no labels. Now that I have one of the answers, I'm going to go back to the original problem. I'll pick either equation. I'll just pick the 3x plus 2y equals negative 10. That's the second equation. You can use any one you want. Excuse me, I'm sorry. So we solved for y, so that 5 over 8 is going to go in there. I want to treat that 5 over 8 just like it's a normal number. I know nobody likes fractions, but as long as you have your calculator, there's nothing different. So 2 times 5 over 8, and if we're not sure what that is, we can use our calculator so it can tell us that it's 5/4. Try thinking that through if you want to in your head. So now I'm just going to subtract 5/4 because we have to treat it like it's a whole number. All right, I'm going to change that to a fraction just for practice. That is 3x, and that equals negative 45/4. And now it's time for me to divide by 3. So I can take my answer and divide it by 3. And there it is. I get negative 15/4 as my answer. I wanted to make sure I did that because I want you guys to see how nice elimination is when it's lined up. The next couple of problems are going to go really fast, and that's because they have special cases to them. So we're not going to graph them, but we're going to look for these keywords from up. I do believe it was on page 2. So we're going to look for words like inconsistent or consistent and independent, consistent, dependent, and then inconsistent. So if you need to pause and go revisit those, please do, okay? Oh, this is definitely set up for elimination. If I multiply the top by 3 and the bottom by 1.5 and give the 3 a negative, I follow the positive and negative rule I was talking about. If you don't understand the positive and negative rule, please come and see me individually because that's really important. So if you can get the process skills on all I need to explain to you tomorrow is that part, that's totally fine. So 3 times 1.5 is 4.5, and that had, negative 4.5, and that has an x. And 3 times 2.5 is 7.5, but what we're going to do, I don't want to have to redo my video for like the 15th time. Okay, that's an exaggeration. Negative 7.5 with a y equals, and then what is that going to be? That's going to be another 7.5 if I'm not mistaken. Yeah, negative 7.5. I got to be careful with my signs. So multiply, multiply, multiply. So there's a positive 4.5. There's a positive 7.5. And if you want to check on the calculator, I mean, there's certainly nothing wrong with that. 3 times, yeah, so it would be 3 times 1.5 for the x, 1.5 times 5 for the y, and then 1.5 times 5. Again, making sure I did everything right. 3, then by 5, then by 5. And they're all positive. Let's look. So usually we're used to this, but look, even the y's cancel out and then these cancel out. So you get nothing here and nothing here. That is an infinite solution problem. If it asks like what's the solution, you would say they're infinite solutions. So if you graphed these would be dependent, consistent lines, like they would fall one on top of the other. It would just be one line. They're the exact same. All right, now the only thing I did different here, and go ahead, guys, you may as well just erase that. And you're going to, you would multiply on this one because I used the same numbers so we could kind of go faster on this one. You would use a -3 and you'd use a positive 1.5 not so that the rules would apply. You would get exactly the same thing. I want you to notice how it's almost the same. The only thing that's different on this one is I made it a -5 instead of a +5. So I'm just going to cheat a little bit and grab this because it's legit the exact same. Remember, the only thing I changed, I don't know where the duplicate went, but that's okay. Let's see, did I actually do it? Good. The only thing I changed was that this is a -5, which would make this is a -5, which make this a -7.5. Now look, you end up getting 0 equals -15, and that is a no solution. We will call those inconsistent. I think it's ENT, inconsistent lines. In other words, visually they'd be parallel because they would never intersect. All right, so far we've gone through three main things. We did how to graph solutions. We did substitution, and we did elimination. We looked at what special cases would be when solving. And the last thing is, quite frankly, you need to learn how to set up word problems. I'm not solving these because we don't have the time. I'm just setting them up. A school that Stefan goes to is selling tickets for a choral performance. On the first day of ticket sales, they sold 3 senior citizen tickets and 1 child ticket for a total of 38. The school took in $52 on the next day by selling 3 senior tickets and 2 child tickets. Find the price of a senior ticket. So that's going to be S, the price of a senior ticket, and the price of a child ticket. So you can see as I read it, I made my equations. This is set up for elimination. Elimination. You would multiply the top by 3 and maybe the bottom by -3, or maybe 1 and -1 if you see it. The state fair is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A filled 8 vans and 8 buses with 240 students. Find the number of students in each van and then students in each bus. So it looks like we're going to do 8 in a van, 8 for 8 buses for a total of 240. And let's see what School B did. They had 4 vans and 1 bus for a total of 54. So there's another one being set up. Again, this one is also ready for elimination. Okay, and you would multiply, and I mean, like what works you could multiply the bottom by -2, but what works all the time is you can just do that trick as well if you're going through and solving this. All right, so again, it's very important that you're able to read the word problems and make your equations. And other than that, just be careful for things that have like fractions as answers. And there is a quick review of solving systems back from Algebra 1.